Hello dear students. In this video I am going to explain again 20 multiple choice questions from the first unit, that is some basic concepts of chemistry. Question number 1. Which of the following pairs of compounds illustrates the law of multiple proportion? Option A, H2O and Na2O. Option B, MgO and Na2O. Option C, Na2O and BaO. Option D, SnCl2 and SnCl4. So here they asked about law of multiple proportion. So law of multiple proportion is nothing but it is having a statement of if two elements form more than one compound between them, then the ratios of the masses of second element which combines with the fixed mass of first element will always be ratio of small whole numbers. So here H2O and Na2O, these are two compounds of different elements. So these two are also different element. These two C also different element. Here D, that is stannous chloride if you take. So if you take the ratio of tin and chlorine in both the compounds, so you will get 119 is to 35.5. That is 119 is the atomic mass of tin and 35.5 is the atomic mass of chlorine. So here if you take for this it becomes 4 into 35.5. So chlorine ratio in both the compounds is, in the first case stannous is same in both the compounds, chlorine is ratio is different. So in first case it is 2 into 35.5 because 2 chlorines are there. In the second compound it is 4 into 35.5, that is 4 chlorines are there. So hence if you simplify this you will get a ratio of 1 is to 2. So here chlorine will combine with the tin in a ratio of small whole number. So mass of chlorine which combines with the fixed mass of stannous will always be ratios of small whole number, that is 1 is to 2. So therefore here the correct option becomes D. Question number 2. The molecular weight of O2 and SO2 are 32 and 64 respectively at 15 degrees Celsius and 150 millimeter mercury pressure. 1 liter of O2 contains n number of molecules. The number of molecules in 2 liters of SO2 under the same conditions of temperature and pressure will be dash. So options are A, n by 2, B, 1n, C, 2n, D, 4n. So for this solution is, so here you have to consider about Avogadro's law. So according to Avogadro's law, equal volume of all gases contain equal number of molecules under similar conditions of temperature and pressure. Thus, if you take 1 liter of one gas containing n number of molecules, 2 liter of any other gas under the same conditions of temperature and pressure will contain 2 into n molecules. Therefore, here the correct answer is option C, that is 2n. Question number 3. Which has highest weight? Option A, 1 meter cube of water. Option B, a normal adult man. Option C, 10 liter of mercury. And option D, all have same weight. . First, 1 meter cube of water is nothing but equal to 10 to the power 6 cm cube of water. So, mass of 10 to the power 6 cm cube water is equal to 10 to the power 6 cm cube into 1 gram per cm cube. So, mass can be calculated by doing volume into density, because density is equal to mass by volume. If you want mass, it becomes mass is equal to density into volume. So, we are having density of water is equal to 1 gram per cm cube. If you multiply volume of water and density of water, you will get mass of water. So, that is here 10 to the power 6 gram, or when you convert into kg, it becomes 1000 kilogram. So, usually weight of normal adult man will be 65 kg. So, density of Hg, that is mercury, is 13.6 gram per cm cube. So, volume of Hg, here they given, that is 10 liter, convert it to cm cube, centimeter cube scale, it becomes 10 into 1000. So, 1 liter is equal to 1000 centimeter cube. So, 10 liter is equal to 10 into 1000 centimeter cube. So, that is 10 to the power 4 centimeter cube. So, weight of Hg again can be calculated by using formula of density into volume, that is density is equal to 13.6, volume is 10 to the power 4. If you simplify this, you will get 1,36,000 gram. So, it can be converted into kg, that becomes 136 kg. So, here if you compare all of these, the most highest weight is having for water, that is 1000 kg. So, normal adult man is 65 kg and 10 liter of Hg is 136 kg. So, 65, 136,000, between them highest one is for water, therefore, the correct option is option A. Question number 4. The number of atoms in 0.1 mole of a triatomic gas is dash. So, given that Na is equal to 6.023 into 10 to the power 23 per mole. So, Na means Avogadro number. So, options given, that is A is equal to 6.026 into 10 raised to 23, option B 1.806 into 10 raised to 23, and option C 3.600 into 10 raised to 23, and option D 1.800 into 10 raised to 22. So, the number of atoms of 0.1 mole of a triatomic gas is 0.1 into 3 into 6.023 into 10 raised to 23. So, 1 mole of any gas, monoatomic gas, contains Avogadro number of particles, that is 6.023 into 10 raised to 23. If you take 0.1 mole, it becomes 0.1 into 6.023 into 10 raised to 23. Since it is a triatomic gas, you have to multiply with the 3. So, 0.1 into 3 into 6.023 into 10 raised to 23. So, answer is 1.806 into 10 raised to 23. So, here correct option is option B here. Fifth question, which has the maximum number of molecules among the following? Option A 44 gram of carbon dioxide, option B 48 gram of ozone, option C 8 gram of hydrogen gas, option D 64 gram of sulfur dioxide. So, let us calculate the number of molecule in each one by one. So, we can calculate number of moles of the moles of a substance by doing mass by molar mass. So, in the first case, that is 44 gram of CO2, mass is equal to 44 and molar mass of carbon dioxide is also equal to 44. So that can be calculated by adding atomic weights of the atoms, that is carbon 12 plus 16 into 2, that is 32. 12 plus 32, it becomes 44. So here mass by molar mass gives 1. So number of molecules 1 Na. In the second case, that is ozone, mass is 48, molar mass is also 48, that is 16 plus 16 plus 16, it gives 48. So 48 divided by 48 is the 1. Moles of O3 is also 1. So here also Na. So number of molecules. Next, moles of H2. So mass is 8 gram and molar mass of H2 is 2. That is 1 for hydrogen, another 1 for hydrogen. 1 plus 1, it is 2. So mass by molar mass, that is 8 divided by 2, gives number of moles of H2, that is 2. Therefore 2 Na. Next, moles of sulfur dioxide. So mass is 64, molar mass is also 64, it becomes 1 Na. So hence maximum number is for H2, that is for H2 2 Na and remaining for all, that is Na. So therefore option is C. Correct option is C. Question number 6. The molality of urea solution in which 0.0100 gram of urea is added to 0.3 dm cube of water at STP is dash. Option A 5.55 into 10 raised to minus 4. Option B 33.3. Option C 3.33 into 10 raised to minus 2. Option D 0.555. So we know that molality is equal to moles of the solute divided by mass of the solvent in kg. So number of moles can be calculated by doing mass divided by molar mass. Mass of urea is 0.01. Molar mass of urea is 60 divided by mass of solvent in kg, that is 0.3. Substitute the value, simplify. The answer will be 5.55 into 10 raised to minus 4. So therefore correct option is here option A. Question number 7. A gaseous hydrocarbon gives upon combustion 0.72 gram of water and 3.08 gram of carbon dioxide. The empirical formula of the hydrocarbon is dash. Options are A C2H4, B C3H4, C C6H5 and D C7H8. 18 gram of water will be containing 2 gram of hydrogen atoms. So therefore 0.72 gram of water will contain 0.08 gram of hydrogen atom. So this can be calculated by doing mass divided by molar mass. So mass is 2 into 0.72 divided by molar mass of water is 18. So it will contain this much gram of hydrogen. Then for carbon also you can calculate similarly. So 44 gram of carbon dioxide will contain 12 gram of carbon. Therefore in 3.08 gram of carbon dioxide, the number of carbon, the mass of carbon will be 0.84 gram. So here also you can calculate by doing mass divided by molar mass. Mass is 12 into 3.08 divided by molar mass is 44. So answer is 0.84 gram. Then you calculate the ratio between carbon and hydrogen. So carbon, ratio of number of carbon in carbon dioxide can be calculated by doing mass divided by molar mass. So mass is 0.84 and molar mass of carbon is 12, molar not atomic mass. Okay. So for hydrogen 0.08 and atomic mass is 1. So if you do the ratios, it becomes 0.07 is to 0.08. So that is 7 is to 8. So therefore the correct option is option D here. C7H8. Number 8, the vapor density of a gas is 11.2. Then 11.2 gram of this gas at NTP will occupy a volume of dash. Options are A 11.2 liter, B 22.4 liter, C 11.2 milliliter and D 22.4 milliliter. So, molecular mass of any gas occupies 22.4 liter at normal temperature and pressure condition. So, vapor density can be calculated by doing molecular mass divided by 2. So, vapor density of any gas occupies a volume of 11.2 liter at NTP. So, here correct option will be option A, that is 11.2 liter, because here if you do the molecular mass divided by 2, so you will get half of the molecular mass. So, therefore, you have to do half of the volume, that is 22.4 divided by 2. So, that is 11.2 liter. Option is A. Question number 9. The molar solution of sulfuric acid is equal to dash. Options are A n by 2 solution, option B n solution, option C 2n solution, option D 3n solution. So, molarity can be calculated by using the formula normality divided by replaceable hydrogen atoms. So, here since H2SO4 is a acid, it is a dibasic acid. So, therefore, molar solution of H2SO4 is equal to n by 2 H2SO4. So, normality is n. Replaceable hydrogen atoms are here 2 number. So, n by 2 H2SO4. Hence, the correct option is here n by 2 solution, that is option A. Question number 10. Equivalent weight of crystalline oxalic acid is dash. Options are A 90, B 52, C 63 and D 45. So, molecular formula for oxalic acid is COOH twice dot 2H2O. So, equivalent weight can be calculated by using the formula of molecular weight divided by 2. So, here you can calculate the molecular weight by using the molecular formula. So, atomic weights of all the atoms present in the molecule, adding them gives molecular weight. So, you will get 126 for molecular weight of oxalic acid. Divided by 2 if you do, you will get the equivalent weight, that is 63. So, hence correct option is here option C 63. Question number 11. At STP, the density of carbon tetrachloride vapors in gram per liter will be nearest to dash value. Options are A 6.87, option B 3.42, option C 10.26 and option D 4.57. Solution. So 1 mole of CCl4 vapor is equal to 12 plus 4 plus 35.5, that is equal to 154 gram. So this is the molecular weight of CCl4. So molecular weight of any gas at STP will be having a volume of 22.4 liter. So density can be calculated by using the values of molecular mass, molecular weight as well as volume. So mass divided by volume gives us density. So mass is 154 divided by volume is 22.4. If you simplify, so density becomes 6.875 gram per liter. So therefore the correct answer is here option A. Question number 12. What is the weight of oxygen required for the complete combustion of 2.8 kg of ethylene? Options are A 2.8 kg, B 6.4 kg, C 9.6 kg, D 96 kg. So first you have to write the chemical reaction for the same reaction, that is C2H4, that is ethylene. It undergoes complete combustion in the presence of oxygen to give carbon dioxide and water. Always hydrocarbon burns or combustion gives carbon dioxide and water. First you have to write the reaction. Then you have to calculate the masses of reactant, that is 28 gram by adding the atomic weights. So this becomes 96 gram. So here 28 gram of C2H4 undergoes complete combustion by 96 gram of oxygen. Therefore 2.8 kg of C2H4 undergo complete combustion by 9.6 kg of O2. So therefore correct option is here option C. Question number 13. 1 Fermi is dash. Options are A 10 to the power minus 15 centimeter, B 10 to the power minus 13 centimeter, C 10 to the power minus 10 centimeter, D 10 to the power minus 12 centimeter. So you remember always 1 Fermi is equal to 10 to the power minus 13 centimeter. So therefore correct answer is here option B. Question number 14. What is the mass of one molecule of carbon monoxide? Options are A 2.325 into 10 raised to minus 23, B 4.65 into 10 raised to minus 23, C 3.732 into 10 raised to minus 23 and D 2.895 into 10 raised to minus 23. So gram molecular weight of carbon monoxide can be calculated by adding the atomic weights of carbon and oxygen, that is 12 plus 16 equal to 28 gram. So 6.023 into 10 raised to 23 molecules of CO weighs 28 gram, that is Avogadro number of molecules will be present in the 1 molar weight of any substance. So therefore 1 molecule of carbon monoxide weighs 28 divided by 6.02 into 10 raised to 23. So this much of molecule weighs 28. So one molecule if you want, you do 28 divided by 6.02 into 10 raised to 23. So answer is 4.65 into 10 raised to minus 23. Hence the correct option is here option B. Number 15. Which of the following halogen can be purified by sublimation? Options are iodine, chlorine, bromine, fluorine. So always you remember iodine undergoes sublimation since it is a volatile solid. Compared to other halogens, iodine is a volatile solid, therefore it can undergo sublimation on purification. Therefore answer is option A here. Question number 16. The mass of barium carbonate produced when excess of carbon dioxide is bubbled through a solution of 0.205 mole of barium hydroxide is dash. Options are A 81 gram, B 40.5 gram, C 20.25 gram, D 162 gram. First, you have to write the equation. So, barium hydroxide on reaction with carbon dioxide, there will be production of barium carbonate along with the formation of water. So, here in this reaction, 1 mole of barium hydroxide reacts with carbon dioxide to give 1 mole of barium carbonate. Hence, 0.205 mole of barium hydroxide also gives 0.205 mole of barium carbonate. So weight of the substance can be calculated by multiplying number of moles with the molecular mass. So number of moles is 0.205, molecular mass is 197.3 for barium hydroxide. So therefore number of weight of substance is 40.5 gram. So therefore correct answer is answer option B. Question number 17. A sample was weighed using two different balances. The results were 3.929 gram and 4.0 gram. How would the weight of the sample be reported? Options are A 3.93 gram, B 3 gram, C 3.9 gram, D 3.929 gram. So out of two values, 1 and 2, 3.929 gram is more accurate because it is expressed in 4 significant figures. So hence it is more accurate. Hence you have to round off 3.929 gram. So you will get after rounding 3.93 gram. So therefore correct option is option A. This is the correct method for the report of the sample weight. Option A. Question number 18. On reduction, 1.644 gram of hot iron oxide gives 1.15 gram of iron. Evaluate the equivalent weight of iron. Options are A 18.62, B 19.13, C 18.95 and D 12.95. So weight of iron oxide is given, that is 1.644 gram. Weight of iron after reduction is given, that is 1.15 gram. So therefore weight of displaced oxygen can be calculated by subtracting weight of iron oxide with the weight of iron after reduction, that is 1.644 minus 1.15. 0.494 is the weight of displaced oxygen. So equivalent weight of iron can be calculated by using formula of weight of iron oxide divided by weight of oxygen displaced into 8. So correct option is 18.62, that is option A. Question number 19. Which of the following is an example of a heterogeneous substance? Options are A. Boiled water, B. Table salt, option C. Pieces of copper, option D. Candle. So if you take boiled water, it is an example for homogeneous substance because throughout the water composition remains the same, that is H2O. Table salt, that is NaCl, that is also example for homogeneous substance because salt will consist of NaCl molecule only throughout the composition. So pieces of copper also if you take, so that is also homogeneous because it contains only one type of atom, that is copper, throughout the matter. Then candle if you take, it is made from paraffin wax, or it also can be made from microcrystalline wax. So or it can be obtained from a gel, a mixture of polymer and mineral acid. So it is not uniform throughout the composition. So for heterogeneous substance, the example is we can give for candle. So therefore the correct answer is D. 20. A colorless liquid used in rocket engines whose empirical formula is NO2 has a molar mass of 92. What is its molecular formula? Options are A. NO2, B. N2O4, C. N2O5 and D. N3O6. So first you calculate the empirical weight, that can be calculated by adding atomic weights of atoms present in the empirical formula. So empirical formula is NO2. So atomic weight of nitrogen is 14. So atomic weight of oxygen is 16. 14 plus 2 into 16 gives empirical weight. Molar mass is given, that is 92. You can calculate the coefficient N by molar mass divided by empirical weight. So that is 92 divided by 46 equal to 2. So this N coefficient into empirical formula gives the molecular formula. So therefore N into NO2 gives molecular formula, that is 2 into NO2, it gives N2O4. So therefore correct option is option B. Thank you students.